Chapter 28, problem number 30. This is a relativistic addition of velocities problem. The spaceship Enterprise 1 is moving directly away from the Earth at a velocity that an Earth-based observer measures to be 0.65 c. A sister ship, Enterprise 2, is ahead of Enterprise 1 and is also moving directly away from the Earth along the same line. The velocity of Enterprise 2 relative to Enterprise 1 is positive 0.31 c. What is the velocity of Enterprise 2 as measured by the Earth-based observer? So let's write down the given information. Enterprise 1 is traveling at 0.65 c relative to the Earth. So the velocity of 1 relative to the Earth is 0.65 c in the positive direction. Enterprise 2 is moving directly away from Earth along the same line, and its velocity relative to Enterprise 1 is equal to 0.31 c. And the unknown is, what is the velocity of Enterprise 2 relative to the Earth? So we start with the Gaussian transformation. I know that V21 plus V1 Earth should be equal to V2E. That will only work, though, for non-relativistic speeds, that is, speeds that are far away from the speed of light, really, really low speeds. But since we're dealing here with speeds that are really fast, we'll get a much more accurate answer if we tag on the relativistic effect, which is the product of, actually it's subtracted, so we're going to subtract the product of the velocities divided by the speed of light squared. So now we need to solve that for V2E. So I'm going to take this term and put it on the left. So we have V2E plus V2E times V21 times V1E all over c squared. And that's equal to V21 plus V1E. Now I'm going to factor out V2E, the unknown. So I have V2E times the quantity 1 plus V21 times V1E all over c squared is equal to V21 plus V1E. Now I'm going to divide both sides by this quantity. So I have V2E then is equal to V21 plus V1E divided by 1 plus V21 times V1E all over c squared. Okay, so substituting in given, V21 is positive 0.31, V1E is 0.65 c, actually there's a c here, so it's 0.31 c, divided by 1 plus the product of V21, which is 0.31 c, times V1E, which is 0.65 c, divided by c squared. So in the numerator, we get 0.96 c, and in the denominator, we get 1 plus 0.31 times 0.65. and I get 0.2015. Okay, the C's cancel. So answer is 0.799 or 0.8 C. So in other words, the velocity of Enterprise 2 relative to the Earth is 0.8 the speed of light. Chapter 28, problem number 32. This is a relativistic addition of velocities problem. Galaxy A is moving away from us with a speed of 0.75 c relative to the Earth. Galaxy B is moving away from us in the opposite direction with a relative velocity of 0.55 c. Assume that the Earth and the galaxies are moving at constant velocities, so they are inertial reference frames. How fast is Galaxy A moving according to an observer in Galaxy B? Okay, so we're looking for the velocity of Galaxy A relative to Galaxy B. We're given the velocity of Galaxy A and the velocity of Galaxy B relative to the Earth. Okay, Galaxy A is moving at 0.75 c away from us. And Galaxy B is moving at 0.55 c away from us. Okay, so, but it's in the opposite direction. So we have to make one of these positive and one of these negative. So let's make this positive and this negative. So I'm going to use the Galilean transformation. I know that VAB plus VBE should be equal to VAE. And I need to take into account relativistic effects. So I subtract from that the product of the velocities. Divided by the speed of light squared. So I need to solve for VAB. This is very similar to the problem I solved previously, number 30, chapter 28. Chapter 28, problem number 31. This is a relativistic addition of velocities problem. A spacecraft approaching the Earth launches an exploration vehicle. After the launch, an observer on Earth sees the spacecraft approaching at a speed of 0.50 c, and the exploration vehicle approaching at a speed of 0.70 c. What is the speed of the exploration vehicle relative to the spaceship? So given information, we have here a spacecraft approaching the Earth at 0.5 c. Okay, so we'll say the velocity of the spacecraft relative to the Earth is 0.5 c. The exploration vehicle is also approaching, but at a speed of 0.7 c. Okay, so this we'll call the exploration vehicle, so I'll say X Earth for exploration vehicle. And they want to know what is the speed of the exploration vehicle relative to the spaceship. So we're looking for VXS. So I'm going to start out with the Gaussian transformation. So I can write that Vxs plus Vse is equal to Vxe. And then I have to take into account relativistic effects by subtracting out the product of the velocities over the speed of light squared. And then the next step is to solve for Vxe, like I did. Very similar, I should say, to the previous problem I went over, number 30.